Hello. I hope this is Desmond who sees it first. Desmond tells me that my videos are content fine but very boring, and so for him I'm going to make sure that today's is just as boring as they have been because I want to be consistent in this way. So, we are talking about generalizing, continuing this guess check generalization theme that we started talking about on Tuesday. But this time, instead of these kind of number problems, the riddles of sorts, we're going to be thinking about word problems more generally. So something where you have like one thing that you're trying to find out, and it would be helpful to come up with an equation. So the first one we've got is Mr. Ely. Mr. Ely runs and plays with his daughters every day. He plays with his daughters each day for 1.5 or 1.5 hours, and he runs the same amount of time each day. Not the same amount of time as 1.5 hours, but it's the same amount of time each day. That was poorly worded. My apologies. After 5 days, he played with his daughters and ran for a total of 12 hours. And this is on your blueprint, so check that out. My question is, how long does he run each day? So I gave the hint and then the requirement that you try guess check generalization for this. So the first thing you really need to be able to figure out when you're doing this is like, what should I be guessing? Like, what is this question even asking me? So we're looking at this and we see we need to figure out how long does Mr. Ely run each day. I'm going to come up with what seems like a reasonable guess. Let's say he runs an hour each day. He might do that. He's trying to run a lot. He ran like 1,000 miles last year. I think that's accurate. I think that was his resolution, which is crazy. So I'm going to guess that he runs 1 hour each day. My guess can be completely wrong, and that is fine, because this next step, check, is what is really going to be important for me to generalize. So if I'm going to be checking this, I need to figure out, well, 1 hour each day, what am I doing with that? He runs 5 days, and it's an hour each day. And he plays with his daughter for 5 days, 1.5 hours each day. Okay, so he's running an hour each day, and he's doing it 5 times because we have 5 days. And so we can label, we've got 1 hour, this is my guess, over the course of 5 days. And then he is also playing with his daughters for 1.5 hours every day for 5 days. And he's doing both of those things, so I would want to combine. Combining would be adding here. And it needs to take up 12 hours over the course of these 5 days. So all of this would need to equal 12. 1 times 5 is 5. 1.5 times 5 is 7.5. So if I had 5 plus 7.5, that would be 12.5. So in fact, is that equal to 12? No, it's not, but that's fine. It was close. It was a pretty good guess. So now I'm going to generalize. And to generalize, I'm going to rewrite my equation so that I can look at that. I had 1 times 5 plus 1.5 times 5 needs to be equal to 12. Is it equal to 12? The only thing that's changing, no matter when I'm guessing, if I were to guess other things, would be this quantity here. That's my guess. So that means that in the logic of this setup, that should be my variable, because that's the thing I don't know. How long does he run each day? And it's the thing that changes with each guess. So let's call that R for how much he runs. I would say R times 5 plus 1.5 times 5 needs to be equal to 12 hours. I can condense this a little bit so that it's easy for me to solve. I'm going to turn this into 5R, just because we've been talking about coefficients. And then 1.5 times 5 would be 7.5, and that needs to be 12. At this point, I could use a number trick, I could use the balance method, I could use an algebraic method. Solving this, I would get that R needs to be 0.9 hours, or 9/10 of an hour. In 7b, we decided to turn all of this into minutes instead, which was nice because you didn't have any decimals to deal with. It meant we had to do more work on the front end, though. And that ended up equaling 54 minutes. So you could play around with that and try the hours to minutes conversion as well. So that's Mr. Ely's situation. We did that one. Everyone looked a little bit downtrodden by the end of that. That was a lot that we were thinking about, especially with these decimals. So then when they got to the next problem, they were like, oh wait, this seems a lot easier to generalize. This time it's the opposite of Mr. Ely running and burning calories. Instead I have Ms. Tess Michael collecting chocolate strawberries. She's gonna love me for this. She has 30 chocolate strawberries, but she wants more. She wants to have 130 chocolate strawberries so she can stash them for months to come. The strawberries come in boxes of 20. How many boxes does she need to buy? There we go, I've got my unknown. How many boxes does she need to buy? So let me guess. What seems reasonable? How many boxes of 20 strawberries might she buy? Let's go with 4 boxes. Not too many, not too few. Seems pretty safe. And it's less important than my check. If she has 4 boxes and each box has 20 strawberries, then I can figure out by multiplying how many strawberries she would have total. And I'm annotating this with arrows. I suggest you do as well. It's really good for communicating and making it clear what it is that you've done. Then she also has 30 strawberries, and a lot of people forgot about this. But she already has those kind of in her pocket or in her stomach or somewhere. And altogether, she's going to need to have 130 strawberries. That's the need or the want. Does that work? 80 plus 30 is 110, so not quite. But that's fine. Not equal. Because now, if I'm going to generalize, I can look at this, and like with the previous problem, the only thing that's going to be changing, as I guess, is the number of boxes. So I could say that my number of boxes could be B. Still going to have 20 in a box, still have 30 extra, still need 130. If I solved this, take 30 away from each side, I'm going to have 100 on this side, and then divide by 20, I'm going to have that B would have to be 5. So she would have to have 5 boxes. 7B like flipped out at this point. It was a really nice way to end the day. But you would need 5 boxes. Moral of this story, once again, don't be afraid to guess. The check is, in my opinion, really the most important part, because that's where you start reasoning about how is this structured? How can you set it up in a way so that you could generalize and solve? And that's all I've got for you. Tomorrow we're going to think about how we can do this with inequalities. And do not forget, you have a test on Tuesday. Goodbye.